So hello guys, welcome back to my video, and this is Mathew Javier. Um, we're going to do a chapter 6 tutorial from CCNA 1. So the first thing we're going to tackle about is the network layer. So a network layer, guys, a network A network layer, guys, is a network applications from services that have one end device can communicate with the application. So it has or other service running on the another end device. How is the data communicated across the network is in an efficient way. So the protocols of the OSI model network layer specify addressing and compresses that enables transport layer data to be packed and transported. So the network layer encapsulation enables data to be passed to the destination within a network or on another network with minimum overhead. So this chapter focuses on the role of the network layer. It also examines how it divides the network into groups of hosts to manage the flow of data packets within a network. It also covers how communication between networks is facilitated. This communication between networks is called routing. So, first is the network layer protocols. Network layer protocols consist of network layer in communication, characteristics of the IP control, IPv4 packet, and IPv6 packet. So, the network layer, first is the network layer. Network layer is a OSI layer 3 for provides services that allow end devices exchange data across the network. To accomplish this end-to-end transport, the network layer uses four basic process. Four basic process is that addressing end devices, encapsulation, and routing, and the encapsulation process. Unlike the transport layer or OSI layer 4, which manage the data transport between the process running on each host, network layer protocols specify the packet structures and processing used to carry the data from one host to another host, operating without regarding to the data carried in each packet allows network to carry packets for multiple types of communication and multiple hosts. So next one is the characteristic of IP control. So characteristic of IP control is encapsulating IP, characteristics of IP connections, IP best effort delivery, IP media independent, and IP characteristic. So encapsulating IP encapsulate the transport layer segment or other data by adding an IP header. This header is used to deliver the packet of the destination host. The IP header remains the same from the time that the packet leaves the source host until it arrives the destination host. That is the encapsulating IP. So the next one is characteristics of IP address. The characteristics of IP was designed as a protocol with low overhead. It provides only the functions that are necessary to deliver a packet from a source to destination. So, if necessary, it interconnected system of networks. That protocol was not designed to track and manage the flow of packet. These functions, if required, are performed by other protocols at other layers, primarily TCP at layer 4. The basic characteristics of IP are described in the figure that is in the chapter 6.1.2.2. So, IP connectionless. Guys, the sender connectionless communication. First, there are two possibilities of the sender and the receiver. So first, the sender doesn't if the receiver is present, if the letter arrives, if the receiver can read the letter. So the receiver doesn't written it is coming. So IP connectionless is a connectionless, meaning that no dictated end-to-end connection is created before data is sent. As shown in the figure in the 6.23, connectionless communication is conceptually similar to sending a letter to someone without notifying the recipient in advance. So, connectionless data communication works on the same principle as shown in that activity. So, it requires no initial exchange of control. Information established on end-to-end devices before packets are forwarded. IP also does not require additional fields in the header to maintain established connection. So the process only reduces the overload of IP. However, with no pre-established end-to-end devices connection, senders are unaware of whether destination devices are present and functional when sending packets, nor they are aware if the destination receives the packet or if they not able to access and read the packet also. So the next one is the IPv4 packet. So guys, are you having thought what is IPv4 packet header? So now I'm going to tell you about IPv4 header. So an IPv4 packet consists of fields containing important info about the packet. These fields contain binary numbers that also examined in the layer 3 process. The binary values of each field identifies various settings of IP packet. Protocols, header diagrams, in which the read left to right and top to down, and provide a visual refer to when discussing protocol fields. The IP protocol header diagram in the figure in chapter 6 is identifies that fields of an IPv4 packet. So significant fields of IPv4 include that a version that contains 4-bit binary set to 0100 that identifies this is an IP version of 4 packet. So next one is the differentiate service or different serve or DS. Next one is time to live or TTL. Next one is protocol. That field is used to identify the next level of protocol. This 8 binary values indicates the payload type that the packet is carrying. So the next one is the source IPv4 address. It contains a 32-bit binary value that represents the source IPv4 access to the packet. That source IPv4 is always a unique address. So destination IPv4 address also contains 32 binary, and IPv4 address of the packet. The destination IPv4 address is a unicast, multicast, or broadcast system, or addresses rather. So the internet high length or IHL total length and header checksum fields are used to identify and validate the packet. So the options and padding fields are rarely used and are beyond the scope of this chapter. So that is an IPv4 packet. So we got IPv6. We have limitations of IPv4, introducing IPv6 and more activity on the chapter 6. So guys, I will introduce to you the IPv6. So in the early 1990s, the Internet Engineering or IEFT grew about the issues of IPv4 began to look for a replacement. This activity led to the development of version 6 or the IPv6 overcomes the limitation of IPv4 and is a powerful enhancement with features that better suit current and foreseeable network demands. So IPv6 provides include increased address force or space. IPv6 address are based on 128-bit hierarchical address as opposed to IPv4 with just 32 bits. It improved packet handling. The IPv6 header has been simplified with fewer fields, so it eliminates that need for NAT or NAT such as a large number of public IPv6 address. NAT between private IPv4 address and a public IPv4 is not needed to avoid some of NAT-induced application and problems experienced by application requiring end-to-end activity. So that is an IPv6 packet. So guys, we are providing the route. We are going to provide at routing. So routing, how a host routes. So this have a host of forwarding decision, default gateway, use or host routing tables and using the default gateway. So host forwarding decision. So host forwarding decision guys is another role that network layer is direct packets between hosts. A host can be sent to a packet itself, a local host, or in a remote host. So the next one is the router routing tables. So router packet forwarding decisions or router the same of the first one, which is the host forwarding decision. This is a router forwarding decision. It also consists of when a host sends a packet to the host, it will use a routing table to determine whether the sent packet if destination is forwarded to the default gateway. The routing table of a router can store in information about direct connected routes, remote routes, default route. So there are also IPv4 routing table, demonstration about IPv4. So now we're going to the routers. Routers, anatomy of a router. So where did it start? Where did it last? So a router is a computer. There are many types of infrastructure routers available. In fact, Cisco routers are designed to address the needs of many different types of business and networks. So first is branch. Teleworkers, small business, and medium-sized branches such as includes Cisco Integrated Service Routed or ISRG. G2 second generation. Next one is one large business organization enterprises includes Cisco Catalyst series switches of Cisco generation or ASR. Next one is service provider. Large service provides the include of Cisco or ASR, Cisco CARS 3 carrying routing system at 7600 series router. So that is all about a router is a computer. So router, CPU, and it OS. So and it has also the thing in chapter 6, the router memory, and what is inside the router, and how to connect a router. So LAN and WAN interfaces also as in this video. So LAN and WAN interfaces. LAN and WAN interfaces, guys, is a connection on a Cisco router that can be grouped into two categories in band router interface management ports. Click the highlight. So console, it had console, the SSH, it also have also the telnet. As we said, console is a physical management port that calls an out-of-band access to Cisco. Out-of-band access refers to access via the dedicated management channel that is used for device maintenance purposes only. So SSH is remotely establishing a remote CLI connection or virtual SSH connection require a active network or service on the internet. So guys, we are proceeding to the next, which is the configure a Cisco router. So guys, this is configuring Cisco router. Configure initial settings, configure interfaces, and configuring the default gateway. So guys, in chapter 6, if you're going to configure initial settings or basic switch configuration step, you should configure the host name. To change the host name, the secure set of line console 0, password, your password, login and exit, line VTY, go to the privilege mode, the password in a privilege mode, which is enable secure your password. To encrypt all of that, service password encryption. To provide legal notification, use banner, MOTD, and your message, and configure management of interface VLAN 1. So that is the switch configuration task. So next one, I configured interfaces. Configuring interfaces, interact type and number, description text, IP address and IP address subnet mask, and no shutdown. So guys, that is all about chapter 6. I hope you learned something from this video, and thank you and God bless to all of you. And again, I am Mathew Javier. Thank you guys.